Solve the following differential equation by using integrating factors. Use C as the constant. So there we go. How are we going to do it? Well, here's the steps. First order linear equations. Step one, put the equation in the form, get dy dx first, then get the y term, and then the x's on the other. The x's that don't have a y on the other side. So I think, okay. So step number one, grab that y, jump it over. So we get y prime minus y is e to the 3x. There we go. We got it in the right form. Step two, find the integrating factor mu of x, which is e to the integral of p of x dx, where the p of x is whatever is right there next to y. Okay, so first of all, what is next to y? Well, there's really a minus one there. That's going to be our p of x. So on step two, when we say the mu, it's e to the integral p of x dx. It's e to the integral. P of x is right there, minus 1 dx. What's that? That's e to the minus x, right? The derivative of minus x would go back to minus 1, wouldn't it? So there's that. That's our integrating factor. Step three, multiply the differential equation by that integrating factor, all three terms by that. So I got to that's my step three here. We bring down my differential equation by y prime minus y e to 3x. Then I'm going to take this and I'm going to multiply it there. E to the minus x there and there. All three. Multiply them all by that. Now, step four says the left side is the derivative of the product. Write it that way. Write it as the derivative of the integrating factor and y multiplied together. So step four, this left side is the d dx of y and the integrating factor, which was that we multiplied through by, which was e to the minus x. And the right side just stays as it was. Well, actually, we can combine things there. How do we do that? Well, these powers will add. It'll become e to the 2x is 3x minus 1x is 2x. Remember, powers add when same bases multiply, powers add. You just have one base. So see what happened on the left side? Look, we can verify the derivative of these guys would go back to here because it's a product rule, right? Two functions multiply. So derivative of the first one times the second one unchanged, plus the first one unchanged, derivative of the second, which is e to the minus x, but times negative 1, because the inside's not a simple x, and there's where the negative comes from. So it's right. The derivative of this side is these two things. That's kind of a nice little trick. And then step five, integrate both sides of the differential equation. So step five, I'm going to actually come in here and I'm going to go integral and integral both sides of the differential equation. And some magic will happen from the dx there. So the dx here, technically. All right, and so what happens? The integral cancels the derivative. They're opposites. So then you just get the y e to the minus x. That's it. It's a real nice trick. Now, on the right side, we're not going to have we're going to have to actually do the integral because why? Because there's not a derivative to cancel it out. So on the left side, we had an integral and a derivative. They cancel each other out. Here we just have an integral. So we got to do that integral. What's the integral of e to the 2x? It's a half e to the 2x. And then we got to put a plus a constant. Right? Because you took the derivative of this, you go times 2 and then cancel that 2 out. And it go right back. So now, last thing, we want y alone. So how do we get y alone? We're going to need to multiply through by e to the positive x times e to the regular x times e to the regular y. Because these will add, remember same basis multiply, add to be e to the 0, which is 1. That'll just get y alone. What happens over here? Again, they add e to the 3x, c e to the x. There we go. That's the right answer. Half e to 3x plus c e to the x. Yeah, you can put that. You can write it like this, or you can factor the half out because it's a different constant. It'll take it either way. And so there we go.